Okay, welcome to lesson 2 of derivatives, and in this lesson we're going to learn the shortcuts for derivatives. We're also going to learn about the difference between differentiability and continuity, but we're going to mostly focus on some of the shortcuts. You're going to like the shortcuts. I know in the last unit we did the formal definition, but in this video you're going to really like the shortcuts. Well, let's just start talking about differentiability versus continuity. If a function is differentiable, this is a differentiable function, it is always continuous. So all differentiable functions are also continuous. But the converse of that does not apply. This is a continuous function, but it is not differentiable at this point. So just because it's continuous doesn't mean it's differentiable. However, if it's differentiable, it's continuous. So differentiability implies continuity, but the converse is not true. And that's really all we're saying about that today. So let's get right into the shortcuts. The first shortcut is that the derivative of a constant is 0. And if you want a visual representation of that, if we have y equals 5, which is a constant, and we were to sketch that, despite the way I've drawn it, this is the derivative of this, the slope of this is 0, because there's no change in that slope. So the slope of this is 0, therefore the derivative of any constant is also 0. This is a very important rule, the power rule, and you really need to take note of it. It basically says that if we have an expression raised to a power, in order to take the derivative, the power drops, so n becomes the coefficient, and then we subtract 1 from the exponent. So an example, the derivative of x to the fourth drops, becomes the coefficient, and then we subtract 1 from the exponent to get 3. So this is 4 minus 1. The same thing over here. We have x to the 8th. The 8 drops, becomes the coefficient. We subtract 1 from 8, and we get 8x to the 7th. That's an important rule. You need to really know that one. The other one is the constant multiple rule. And the constant multiple rule just says that if I have a function, so if I'm taking the derivative of, let's say, 2x to the 8th, I can write this, I can pull out the constant, which is 2, and just take the derivative of x to the 8th. So we know from the previous slide that the derivative of x to the 8th, the 8 would drop, and then we subtract 1 from 8 and get 7, and then we would simply just multiply that by 2. So this derivative would be 16x to the 7th. The sum and difference product just says that if we add two functions, if we take the derivative of two functions being added together, we can take each derivative separately and add them together. And the same thing with subtraction. So this would be like the derivative of x to the 4th plus x to the, 1/2 would be the same as saying the derivative of x to the 4th plus the derivative of x to the 1/2. And of course, the derivative of x to the 4th would be 4x cubed, and this would be plus 1/2 x to the negative 1/2, which is going to bring us to, I think, our next slide. Yes, so the derivative of the square root of x, or x raised to the 1/2, can be written like this. And we've just seen from the product rule why this is true, because I can write this as x to the 1/2 and then just use the power rule on it. The derivative of trig functions, the only thing I can say about this is to memorize them. Just memorize them. Also, if you want a pattern, the codes are always negative. All the codes are negative. But the only thing I can tell you about this is just to memorize them. You see cosine and sine a lot, so those two you pretty much get. Tangent and secant we also see a lot. It's generally, well, the one I have a hard time remembering is cotan x and cosecant x, but we just have to memorize them. Remember, the codes are already negative. E to the x is my favorite because the derivative of e to the x is e to the x. And natural log of x, the derivative of natural log of x is 1 over x. And again, this is just something that you have to memorize. So let's do some examples. We're going to start with some easy ones, and if you would like to pause this and practice on your own, see which ones you can get, and then come back and see the answers, that would be a great idea. So I'm just going to kind of do a few of these. Well, I'm going to do them all. But the first one is x cubed, and so we're going to use the power rule on that. So the 3 is going to drop, so I'm going to write this as f prime of x. The 3 drops, and then I subtract 1 from the exponent, and I get 3x squared. Cosine x, I just have to go refer back to the list, and I know that the derivative of cosine x is negative sine x. Once again, referring to the list, now I'm taking the derivative of two different things. So I'm taking the derivative of natural log of x and then the derivative of 5 with respect to x. So the derivative of natural log of x we found to be 1 over x, and the derivative of 5 is 0 because 5 is a constant. For a problem like this, you have to rewrite it in terms of so that you can use the power rule. So we know that 1 over x squared can be written as x to the negative 2. So now once it's in this form, we can just use the power rule. So once again, the negative 2 will drop, and we subtract 1 from negative 2, which gives us negative 3. Be careful with that. A lot of students make the mistake of saying negative 1, but remember negative 2 minus 1 is negative 3. Okay? For this one, we have to take the derivative of each of these individually. So the derivative of 5x to the 4th, again, we do 4 times 5 and subtract 1 from the exponent. 3 times 2, subtract 1 from the exponent. And then we have to recall that the derivative of e to the x is simply e to the x. For this one, it may make our life easier to rewrite this as x to the 2/3. And once it's written as x to the 2/3, I can now take the derivative of this. I can use the power rule. So the derivative, 2/3 drops, and I subtract 1 from 2/3 and get negative 1/3. Here, the negative 2 drops, so I have minus 2, x to the subtracting 1, and then I remember that the derivative of sine x is cosine x. Now for this one, there may be a temptation to say, well, this would be 2x times 3, but we can't do that. Later in the next unit, we're going to learn the product rule. So we cannot do that. That is bad math. The only thing that we know at this point is power rule. So we're going to have to manipulate this so we can use the power rule. And I can do that simply by simplifying this expression. Okay? Then I take the derivative. Now once again, when we multiply two functions, we're going to have to use the product rule, which we have not learned yet. We'll learn that in the next lesson, or maybe the lesson after that. So then h prime of x, now that it's simplified, I can use the product rule. So that's going to give me 9x squared minus 2x. Okay? Again, for this one, the temptation is to find the derivative of the top, find the derivative of the bottom, and just divide. But again, we can't do that. We have to use the quotient rule, which we don't know yet. And since we don't know the quotient rule, we can simplify this. So simplifying this, I get 3/4 over x, 3/4 times x, plus 8x divided by 4x, because I'm just dividing this 4x into all three of these. 8x divided by 4x is 2, and then this would be 2 divided by 4, which is a half, and that'll be x to the negative 1. So now I can use the product rule, the power rule, on each of these. So h prime of x would be the derivative of 3/4 x. Remember, this is raised to the first power. So 1 times 3/4 is 3/4. And at 1 minus 1 would give me x to the 0. Well, anything raised to the 0 power is 1, so this is just 3/4. The derivative of 2 is a constant, so it's 0. And then negative 1/2 times negative 1 gives me positive 1/2. And negative 1 minus 1 to the negative 2. Okay, again, for this one, we're going to have to multiply this out or use chain rule, which we don't know yet. We're going to learn chain rule in a minute. I think in couple of videos, you're going to like the chain rule. It's one of my favorites. Okay? So now that I have this multiplied out, I can now just take the derivative using the power rule. So that's 2x minus 10, and the derivative of 25 is 0 because it's a constant. And we're now going to do this last one. Again, it's just memorizing the formulas. We know that the derivative, if you check back at your notes, we know the derivative of tan x is secant squared x, and the derivative of secant x is secant x tan x. Okay, the last problem. What we have to do with this one is we're really going to have to still divide this through. So we're just going to have to use our algebra skills to divide this through. And I get j of x is equal to 3 over 4. I'm sorry, I don't know where I got that 4 from. I just made it up. Is equal to 3. And we subtract exponents, so I have 4 minus a half, which is 7/2. Plus 4, 2 minus a half is 3/2, plus 3x to the negative 1/2. Now, we just use the power rule to solve this now. So I get j prime of x is equal to 21, x to the subtracting 2 over 2 from that gives me 5/2, plus 4, plus, what is that, 6, x to the 1/2, and that's going to be minus 3/2, and that should be 21/2. Sorry. 7/2 times 3 is 21/2. Sorry, I forgot about the 2 at the bottom. And that's 12 divided by 2 is 6, and this is negative 3/2, x to the negative 3/2, because we subtracted 1. So that gives me x to the negative 3/2. Okay. Alrighty, let's go ahead and finish this. Okay, I think we have time to finish the next one, the next section. So in this section, we're going to look at writing the equations of a tangent line, finding horizontal and vertical tangents, and we're going to work on becoming a little bit more proficient in some of our examples. Okay, so I want you to recall from what we did earlier, the point-slope formula. So remember, we use the point-slope formula when we have a point and a slope. Well, that's the slope, and we have a point. Okay, so we use it when we have a point and a slope. And remember also that slope is the same as derivative. So in order to write the equation of the tangent line, and I should specify this is the tangent line, we have to find the derivative. Remember that the derivative is the slope. Then find the derivative at a particular point, and then use the point-slope formula to write the equation. So I've done this one for you. So we start off by finding the derivative of f of x. So using the power rule, we found that this was 6x squared minus 3. Then I have to find the slope at that point. So I find the slope at negative 1 by substituting negative 1 into the slope formula, which gave me 3. So now I'm going to use the point-slope formula because I have a slope and I have a point. So it's y minus y1 is equal to m, which is my derivative, times x minus x1. And it's okay to leave your answer in this form. You want to leave your answer in this form because it's easy to make mistakes with this, so just leave your answer like that. Let's talk a little bit about the secant line and the tangent line. We've already talked about the secant line in lesson 1. I just want you to recall that the secant line is simply a glorified formula for slope. So this is the same as saying y2 minus y1 over x2 minus x1. It's the exact same thing. The instantaneous rate of change is the derivative at that point. The instantaneous rate of change is the derivative at that point. And remember, that's our slope. So let's do an example. We want to find the average rate of change and the instantaneous rate of change. So the average rate of change is going to be f of 2, because we're finding the average rate of change from 2 to 0, minus f of 0 all over 2 minus 0. So to find f of 2, I simply substitute 2 in for x. So that gives me 3 times 2 squared plus sine of 2. And 2 squared is 4, so that's 12 plus sine 2. F of 0 is going to be 3 times 0 plus sine of 0, which is simply 0. So I do f of 2, 12 plus sine 2, minus 0, all over 2 minus 0. Or we can write this as 12 plus sine 2 over 2. And yes, that is a perfectly good answer. I prefer that you not round unless it calls you to. So to find the instantaneous rate of change at 2, I have to find the derivative. So I have to find the derivative of 3x squared plus sine x. And the derivative of 3x squared plus sine x is going to be 3 prime of x is equal to. I use the power rule on 3x squared, which gives me 6x. And the derivative of sine x is cosine x. And then I evaluate that at 0. And that is our answer. Yay. Okay, let's talk about horizontal lines and tangent line and vertical tangent lines. A horizontal tangent line occurs when the derivative is 0. So in order to find that, we're going to set the numerator equal to 0. Vertical tangent lines occur when the denominator is 0. So we set the denominator equal to 0. The normal line is perpendicular to the tangent line. So the slope of the normal line is equal to 1 over negative 1 over m, the slope of the tangent line. Okay? So let's do this example. They ask us to find any horizontal tangents. So the first thing I have to do is find the derivative. So 3 times a third is 1, and this will be x to the negative 2/3. Or I can write this as 1 over x to the 2/3. So my first question is, when is 1 over x to the 2/3 equal to 0? Okay? This is never equal to 0. So there is no horizontal tangent line, because the numerator for this is never 0. To find the vertical tangent line, I take the denominator and set it equal to 0, because this happens when the derivative is undefined. So that would be x to the 2/3 is equal to 0, and that happens when x equals 0. So we have a vertical tangent line at x equals 0. Then they want us to find the normal tangent line. So to find the normal tangent line, I have to start by finding the slope at 8. So we know that the slope at 8 would be 1 over 8 raised to the 2/3 power. And 8 raised to the 2/3 is 4, so this is 1/4. So the normal tangent line is the reciprocal of the regular tangent line, and we take the opposite of it. So the normal tangent line is going to be negative 1 over 1/4, which is negative 4. And they want us to find the equation for that. So to find the equation is y minus y1 equals mx minus x1. So y1, I would go back to the original equation and evaluate f of x at 8, which would give me 3 times 8 raised to the 1/3, which is 6. So y1 is 6, and x1 is 8. So my point is 8, 6. My slope is negative 4, so I have y minus 6 is equal to 8, x minus right. Put the things in the wrong place. Negative 4x minus 8. Okay. All righty. I want you to memorize the basic derivatives, and there are practice problems on pages 16 and 17. You really just need to sit down and work those out, and then the answers to those are online. In case you have any questions, I know that was a lot we covered, so if you have any questions, remind me. I will see you in the next lesson.